Hi everybody, here we are with another in our series of tutorials on porosity. What I want to cover with this video is the Sheffield method, the Sheffield porosity method. The Sheffield unit itself was developed in the 1950s. There were the predecessors, certainly the Benson test was a predecessor, the Gurley test was a predecessor. What the Bendix folks were looking for was a quicker way to give some indication to the production people what that structure looked like. Again, relatively speaking, if you have a structure, you have nooks and crannies, you can force air through it under certain conditions, and you can get an idea of what's happening. If you're making production changes, you're tightening the web up or you're opening that web up, or if you're coating, you're doing some coating action. So certainly that's going to change the porosity. So the test itself was developed in the 50s. The method, the tapping method that most people are following today, that wasn't really developed and actually put into like service, if you will, until the 1980s. So a long time in between the actual development of the instrument to the development of a method to follow. I think one of the reasons behind that certainly was the idea that the Sheffield unit was never meant to, this is just some anecdotal information that I have, but never meant to be an instrument that you could use in one facility and compare that to the results in another facility. They didn't design this system in such a way that it was going to be tightly repeatable, reproducible from one location to another. So I think that's one reason maybe TAPI or ISO held off and waited until some future developments took place before they turned it into an actual method. So when we're looking at this unit, again, I want to go back just to reinforce everybody to let them know that we're talking about, let's say, the original, the vintage development of this particular method. Some of the similarities between all of these methods, as I mentioned, were the clamping mechanism. You have to have some method to clamp the sample and define that area that you're trying to test and push air through. You have to have some way to develop a pressure differential. Without pressure differential from one side to the other of the sheet, you don't get any air movement at all, thus you don't get any measurement. So the Sheffield folks, again, they looked into their engineering group. They came up with a couple of different ideas that were a little different from the Benson test and also the Gurley test. They were going to be using, let's say, mill air for their pressure supply. All right, mill air sometimes is a little bit, needs a little bit of attention to clean it up, but their idea was to use the mill air. It was easy to connect to, readily available. They used a clamping mechanism similar to what I have here on the table, with the exception that they had a rubber diaphragm on the top side and the bottom side, and that diaphragm was put together in such a way that it defined the area that we were going to test. Though probably one of the more common test areas that has been used certainly in North America and Canada was the 3/4 inch orifice diameter. Okay, the 3/4 inch orifice diameter was big, I think, extra big in the production of newsprint. Newsprint was developed, years and years and years ago. Now this particular method, although it's still utilized for a number of different grades, newsprint, certainly, as you know, that particular product is not certainly a growing industry. But nonetheless, the 3/4 inch orifice diameter became the most popular. So we've defined the area that we're pushing this air through. We found a method in order to create a pressure differential. Now we need the means to measure this flow. The measure was developed using rotometer tubes. In the Sheffield case, there were 3 tubes one running roughly from 0 to 60 Sheffield units, the next running from roughly 60 to 170, and the third running from roughly 170 up to 400 Sheffield units. 400 Sheffield units is in fact the top of the Sheffield scale. We have been asked to produce a value that's higher than the 400 Sheffield unit. We can certainly do that with some more modern equipment, but we're not 100% sure what that means relative to the original Sheffield method. So if I want to look at this test and compare it to some standard flow values, milliliters per minute as an example, that can happen certainly, but it's interesting, and again, go back to the original, the developers, they put together these rotometer tubes. They were very good at developing air leak test measurements systems. So they used these 3 rotometer tubes, somewhat arbitrary as far as what their units were producing. And the relationship between the Sheffield unit and milliliters per minute, or engineering units, is like I have in a drawing here behind me. The first tube, 0 to roughly 60 Sheffield units, has a slope that is related here on my first section of my graph. That slope is roughly 6, maybe 6.8 milliliters per minute per Sheffield unit. Okay, so there's certainly a slope here. The next you can see, which represents the relationship between milliliters per minute and the center tube, runs from, again, roughly 50 Sheffield units up to around 180, 190 Sheffield units. That slope, you can see, that slope is a little bit lower than the first slope. That's something that you'll find all the defined slopes and intercepts in TAPI T4 547. And then finally, the relationship to the Sheffield unit in the third tube looked something similar to this. So now we have, again, a little stronger slope than the original. If you average all 3 of these slopes out, it comes to somewhere around 8 milliliters per minute per Sheffield unit. To give you an idea, if you are familiar with engineering units as far as flow is concerned. So, as I mentioned, 3/4 inch orifice diameter, that became maybe I don't think it was by design, but by happenstance, that became the most popular. The other orifices that are available, certainly if you have an more open sheet, okay, one way to let's say reduce the amount of airflow and still be able to measure within your working range of your measurement system, neck that orifice down. So they have a 3/8 inch orifice that can be used. You neck that down, you have maintained that same pressure differential, which is 1.5 psi between one side and the other of the sheet. And now you get a little lower airflow, and you can actually measure it with your measurement system. The same thing occurs on the tighter side. They had produced a 1.5 inch orifice diameter, a 2.25 inch orifice diameter, and a 3 inch orifice diameter. And again, mainly to try to accommodate the wide range of products that were available at the time. Certainly those products are maybe even expanding today. So utilizing a different orifice diameter certainly will help you to be able to use this instrument for a wide range of working products. Now, one thing to keep in mind, even though we can develop a relationship between milliliters per minute and this scale, you still have to keep in mind that if you switch from one orifice diameter to another orifice diameter, even though you're reading on this particular scale, 170 Sheffield units, doesn't necessarily mean the same thing with a 1.5 inch orifice diameter that it does with a 3/4 inch diameter. So you have to keep that in mind when you're looking at results or comparing results. Customers giving you some results, make sure you understand what orifice diameter that they were testing under at the time they gave you those results. Okay, so the the system has a clamping mechanism. We talked about that. We talked about a way to generate the pressure differential from one side of the sheet to the other. So we defined the area that it's being tested under. We defined the pressure differential that is being tested under, and now we have a measurement system that we can test it under and produce these results, hand them off to. And if we're talking to our customers, we're talking between quality lab and the production people, at least we're talking about the same, using basically the same language when we're using the Sheffield method. Alrighty, so hopefully that gives you an idea of where some of the Sheffield information or Sheffield results that you might see today, might hear about today, where that information came from, and please come back and listen to some other videos or some of the previous videos that I talked about. I've already covered Benston, we've looked at Gurley, we'll also look at Fraser, and touch a little bit on Caresta. Caresta is used mostly in cigarette manufacturers, so we'll just touch a little bit on that later on in another video. Alrighty, thank you very much, and hopefully we'll see you again.